The coldest place in the universe is not on Pluto, not in the void between galaxies, not anywhere nature put it. Humans built it deliberately in a laboratory the size of a small room. And the temperature they reached is so extreme that every physics textbook you ever read had to be quietly updated. If you passed your science class believing outer space was the coldest thing possible, that answer was already wrong before you graduated. Deep space sits at around 2.7 degrees above absolute zero, which sounds brutally cold until you hear what physicists pulled off inside a metal chamber on solid ground. They cooled matter down to within a billionth of a degree of the lowest temperature the universe theoretically allows. That number is so close to the absolute floor of reality that it stops feeling like a measurement and starts feeling like a dare. The place is real, the temperature is verified, and the physics it unlocked changed everything. Temperature is just a measure of how fast atoms are moving, and that changes everything. When something feels cold, its atoms are moving slowly, vibrating with less and less energy. Push that idea to its logical end, and you arrive at a place where all atomic motion stops. That stopping point has a name: absolute zero, sitting at negative 273, 15 degrees Celsius, or negative 459, 67 Fahrenheit. It is not just the coldest temperature ever recorded, it is the lowest temperature the laws of physics will allow to exist. Below it, there is nothing, no colder state, no further step. Down, just a hard wall built into the fabric of reality itself. Even the emptiest regions of deep space hover a few degrees above this limit, warmed faintly by the leftover glow of the Big Bang. So, when scientists talk about reaching absolute zero, they are not chasing a record on a thermometer. They are pressing their hands against the floor of the universe. Deep space sits at about 2.7 degrees above absolute zero, and for a long time that felt like an unbeatable number. Then physicists decided they weren't satisfied, and they built something genuinely stranger than the void itself. The tool they reached for is called a magneto-optical trap, and it sounds exactly as serious as it is. Lasers fire at a cloud of atoms from every direction, slowing each particle down to an almost impossible crawl. When atoms slow down, their temperature drops because temperature is really just a measure of how fast things move. Researchers then layered a second technique on top, called evaporative cooling, which strips away the fastest atoms the way steam lifts heat from a hot cup. What remained was a gas cooled to a fraction of a billionth of a degree above absolute zero. That number isn't a rounding error. It's a deliberate achievement no corner of the natural universe has ever matched. The cosmos went cold by accident. Humans went colder on purpose. Chasing absolute zero was never just about owning the coldest thermometer on the planet. Every fraction of a degree closer to that limit has unlocked something genuinely new about how matter actually behaves. At these temperatures, electrons stop acting like particles and start flowing as one frictionless, unified wave. That's the engine behind superconductors, which could one day carry power across continents without losing a single watt. Quantum computers need this cold to keep their fragile calculations from collapsing into noise. The atomic clocks that make GPS accurate to a meter rely on ultra-cold atoms to stay precise. And some of the strangest predictions in physics, things that seemed purely theoretical, only became visible once we got cold, enough to see them. The record itself is almost beside the point. What matters is that every time we pushed the temperature lower, the universe showed us something it had been hiding all along.